Section: Introduction. In this section, we explore the impact of generative AI on the distribution of knowledge within human society. Before the rise of generative AI, all text and artwork were created by humans, sometimes with the help of tools or computer systems. Large language models, LLMs, now have the ability to generate text, images, audio, and video with minimal human effort. This shift towards AI-generated content raises concerns about how it may affect human thought, information seeking, and knowledge in the future. While some researchers have focused on the negative effects of AI, such as spreading false information through deepfakes or biases in algorithms, we are interested in understanding how the widespread adoption of AI-generated content could impact the overall distribution of knowledge in society over time. As AI systems become more integrated into our daily lives, there is a risk of what we call a curse of recursion, where our access to diverse human knowledge becomes increasingly limited to a narrow subset of viewpoints. This narrowing of knowledge distribution could lead to certain popular beliefs being reinforced while less common ideas are neglected and eventually forgotten. This process may be exacerbated by an echo chamber effect, where individuals are repeatedly exposed to a limited set of information, leading them to undervalue less mainstream knowledge. Additionally, the ease of access to information provided by AI may result in a streetlight effect, where individuals focus their search efforts on easily accessible information rather than exploring more valuable but less visible knowledge. This narrowing of knowledge distribution could have significant implications for fairness, diversity, innovation, and the preservation of human culture. We propose a simulation model to explore how individuals might actively curate their information sources to prevent knowledge collapse caused by AI-generated content. By investing effort in seeking out neglected knowledge areas, individuals can help mitigate the negative effects of AI on knowledge distribution within society. Our work highlights the importance of balancing the convenience of AI-generated content with the preservation of diverse knowledge sources. We also discuss potential solutions to prevent knowledge collapse in the era of AI. Section Summary. In this section, we explore the potential consequences of AI-generated content leading to knowledge collapse by neglecting diverse knowledge sources over time. We introduce a model where individuals decide between relying on convenient AI technology or investing in a broader range of knowledge. Through simulations, we investigate how well-informed individuals can prevent knowledge collapse and suggest possible solutions to maintain a diverse knowledge landscape in the AI era. Section: The Media, Filter Bubbles and Echo Chambers. In this section, we discuss the impact of social media on users' exposure to information through echo chambers and filter bubbles. We acknowledge the criticism that social media platforms can lead us to engage only with like-minded individuals and content, reinforcing our existing beliefs. This can contribute to political polarization. The concept of echo chambers suggests that individuals with similar ideologies interact more frequently, creating a polarized environment. This phenomenon is assumed to be more prevalent on social media compared to traditional media due to the personalized nature of content delivery. Filter bubbles, on the other hand, refer to the personalized content recommendations users receive based on their interests and behavior. These recommendations aim to maximize user satisfaction but may inadvertently lead to selective exposure and polarization. Recent studies suggest that advanced algorithms may further enhance this bias by reinforcing existing opinions based on subtle cues in user queries. Popularity bias in recommendation systems can also limit users' exposure to diverse content, as popular items receive more visibility while niche interests are marginalized. This can lead to user disengagement and a lack of variety in content consumption. Efforts have been made to address this bias and promote a more inclusive information environment. Information cascade models help explain herd behavior where individuals make decisions based on others' actions rather than private information. These models explore how information spreads within networks and the impact of network structure on information diffusion. Factors such as social influence, ideological preferences, and topics can influence the spread of information within a network. Overall, Understanding how information flows within networks, including the role of recommendation algorithms and user interactions, is crucial in navigating the complex landscape of social media and the Internet. By studying these dynamics, we can gain insights into how information is shared and how opinions are formed in the digital age. Section Summary. In this section, we explore the impact of social media on users' exposure to information through echo chambers and filter bubbles. Echo chambers refer to users being exposed to content that aligns with their existing beliefs, potentially leading to political polarization. Filter bubbles, on the other hand, result from recommendation systems showing users content based on their past behavior, potentially reinforcing biases. Additionally, information cascade models are discussed, which explain herd behavior and how private information may not be efficiently aggregated in public decision-making processes. Section: Model Collapse. In this section, we delve into the concept of model collapse. The notion of model collapse originates from the phenomenon of mode collapse, observed in generative adversarial networks, GANs. GANs consist of a generator neural network that generates images and a discriminator that distinguishes between generated and real images. Sometimes, the generator may end up producing a limited set of images to deceive the discriminator, known as mode collapse. Another related issue is posterior collapse, seen in variational autoencoders when modeling language data. We introduce the term model collapse to describe a similar process in various models like variational autoencoders and Gaussian mixture models when trained on data generated by an earlier version of the model. When artificial intelligence, AI, generated content is included in the training data, it can lead to information loss categorized into early model collapse and late model collapse. The former involves losing distribution tails due to errors, while the latter occurs when a model converges on a narrow distribution different from the original data. We provide evidence of model collapse in models like LLMs and demonstrate that even a small amount of synthetic data can negatively impact the model. Training LLMs on synthetic data can reduce diversity in lexical, semantic, and syntactic aspects. Despite advancements, LLMs are still prone to biases, struggle with representing minority viewpoints, and oversimplify text generation. Efforts to mitigate biases include adjusting prediction strategies and evaluating input data importance, but our understanding of LLM mechanisms remains limited. Furthermore, we discuss the concept of knowledge collapse, highlighting how knowledge may not always progress consistently over time. Historical examples like the loss of ancient recipes or languages emphasize the progressive narrowing of available information. The distribution of knowledge among individuals has also evolved, impacting our perceptions and values. Knowledge collapse refers to the gradual reduction in accessible information over time, along with a decrease in the perceived value of diverse information sets. This narrowing of knowledge availability can render theoretically accessible information neglected and useless if deemed unworthy of pursuit by individuals. Section Summary. In this section, we explore the concept of model collapse, which is a phenomenon observed in various AI models like variational autoencoders and language models. Model collapse can occur when training data includes AI-generated content, leading to loss of information and diminishing diversity in the model's outputs. Additionally, we discuss biases in newer AI models such as LLMs, which struggle with representing minority viewpoints and exhibit limitations in generating human-like texts, highlighting the challenges in addressing these biases effectively. Section: Model Overview. In this section, we focus on whether individuals choose to invest in innovation or learning, which we consider to be the same thing. We look at whether they do this in the traditional way, through a possibly cheaper AI-enabled process, or not at all. For example, we compare someone who does thorough research in an archive versus someone who relies on easily accessible materials, or someone who reads a full book versus a 2-paragraph summary generated by AI. Humans, unlike AI models trained by researchers, have the ability to choose among different inputs. Therefore, a key aspect of the model is to consider that rational individuals may be able to avoid or correct distortions caused by relying too much on mainstream information. If historical data overlook the extreme ends, the benefits of such knowledge should be higher. When individuals notice this, they would be willing to invest more effort to gain from these additional benefits. We explore when individuals updating their knowledge is enough to maintain an accurate understanding of the truth for the whole community. The decision to invest in new information depends on the expected value of that information. Anyone who experiments with AI, for example, for text summarization, develops a sense of when AI provides the main idea well enough for a specific purpose and when it's better to go directly to the source. We assume individuals cannot predict the future, but they can see the rewards from previous rounds. The decision also depends on each individual's characteristics. We have a group of individuals with different characteristics drawn from a specific distribution. These characteristics could represent different expected returns from innovation or their ability and willingness to engage in innovation. We model knowledge as a process of approximating a probability distribution. This is a simplification to work with a process that has known properties, with a central mass and long tails, reflecting the nature of knowledge. Individuals who invest in information get a sample from the true distribution, while those investing in AI-generated samples get a sample from a modified true distribution. To adjust the tail mass, we model the true distribution as a student's t-distribution. The results are similar for a standard normal distribution, and wider tails lead to more significant knowledge collapse issues. When individuals invest in innovation, they also contribute their knowledge to the public. A public knowledge distribution is created by combining the most recent samples, indicating the overall welfare of society. Knowledge collapse happens when there is a growing gap between public and true distributions due to tail regions collapsing and more mass near the mean. Individual payoffs depend on how much they move public knowledge towards the truth. Individuals cannot predict the future value of their innovations but update their beliefs based on previous rounds. The public knowledge is updated based on all samples, reflecting the collective nature of knowledge evaluation. Investments in innovation benefit public knowledge, but too much focus on popular information can distort knowledge. We also consider generational turnover in some models, where new generations base their knowledge on the previous one, potentially limiting their search for new information. This turnover can be seen in human generations or in recursive dynamics among AI systems. Section Summary. In this section, we focus on whether individuals choose to invest in innovation or learning, either through traditional means or AI-enabled processes. We explore how rational agents can prevent distortion from over-reliance on central information and how investing in new information depends on its expected value. By modeling knowledge as a process approximating a probability distribution, we investigate how individual investments contribute to public knowledge and the potential for knowledge collapse if too many individuals rely on popular or central information sources. Section: Results. In this section, we focus on the idea that AI could potentially improve our lives by making certain information more accessible. Unlike previous studies on model collapse, we explore how people might actively seek out data that preserves a wide range of knowledge. We start by looking at different discount rates. Initially, we show a graph of public knowledge after 100 rounds without any AI discount, where public knowledge aligns closely with the true distribution. However, when AI makes truncated knowledge cheaper, public knowledge shifts towards the center, neglecting the less common information. Relying heavily on AI-generated content gradually limits diverse perspectives, distancing public knowledge from the truth. By adjusting specific parameters, we can gauge the impact of relying on AI. For instance, in our standard model, after 9 generations, with no AI discount, the public knowledge is very close to the true distribution. But with a 20% discount, the distance increases, and with a 50% discount, it increases even more. This shows that cheap AI approximations can actually move public knowledge further away from the truth. We then analyze how updating on the value of samples and the discount factor affect public knowledge. Faster updating and cheaper AI content lead to a collapse of public knowledge towards the center. Conversely, slower updating can offset extreme price differences. We also study how extreme truncation of AI-generated content impacts knowledge collapse. Severe truncation results in a narrower perspective, while less extreme truncation allows for a broader representation of viewpoints. Additionally, we examine the effect of generational changes on public knowledge. Without generational change, there is only a slight reduction in the tails of knowledge. However, introducing generational change causes a noticeable shift, regardless of how frequently it occurs. Our study defines knowledge collapse due to reliance on AI, highlighting the importance of preserving diverse perspectives and ensuring AI content represents the full range of knowledge. We suggest measures to prevent over-reliance on AI and emphasize the need to avoid recursively dependent AI systems. It is crucial to maintain access to unmediated texts and prioritize diverse inputs and outputs. Finally, we stress the significance of considering the representativeness and variance of AI-generated answers, especially in educational settings.